Okay, ladies and gentlemen, sorry about that. Let's see where we're at. Oh, apologize. Where's my water? So what I'm going to say to you guys, your solutions will be published a little later. Let me pass back your test. Good. Pass it back. Okay. Your solutions will be public later today. Okay? So you guys can double check where you went right, where you went wrong. Anyway. Remember what we're going to work on. Hypothesis what? Testing. I'm going to talk about today the procedure. So this stuff is easy. We focused a little bit on some language. So here's where hypothesis testing is. And here's some notes for you guys. I put them in the chat yesterday. And we're going to see what this is really about, okay? So I'm going to go back out here to the iPad, and we're going to go through this stuff. So ladies and gentlemen, all I got to say is that, this stuff is easy, it's doable, but if you don't keep up to date with homework, what happens? It'll swamp you, and you'll come to regret it. You guys know what I'm saying? Yeah. The key is consistency. If you want to get good at anything, you got to be consistent. If you're inconsistent, you don't make progress. So keep up with that. And, people, like I said, have done very well with this in the past. I don't see why you can't continue, but okay. Hypothesis testing, AKA the what? Scientific method. All right. And we talked about what a hypothesis was yesterday. I have some examples, and I do have on the website, if you guys are interested in looking at, other videos there that I've posted that I've done. They're from me. They're not from anybody else. But I want to go through the procedure here and mention it to you. So if you want to see additional examples, they're there. And so we talked about the two types of hypotheses, the null and the alternate yesterday. Is that true? Yeah. Now, these are some other, examples of hypotheses that we'll get to. But I want to talk about the procedure today and show you an example of the hypothesis testing procedure. And we're going to get started on that procedure because the sooner we get started, the better. But don't save this till when? The night before the test, because you're focusing on other things that you feel are more important. It'll come back to haunt you. So this is the hypothesis testing. It's based on taking a what? Sample. So you're going to end up taking a sample. And in that sample, you compute what we call a test statistic. Okay, so you say, we're going to test our hypotheses today. And essentially, you're going to draw a conclusion from what we call a decision rule. And we do have three types of hypothesis testing formats. But what I'm going to focus on to just get started is really what we call the two-tail test. Okay, so this is my focus today to get started is what's known as the two-tail test. Now, there's going to be a process that you follow. Okay, the first portion here is what I call, you're going to have to set up your hypotheses. Set up these hypotheses, okay, decision rule. So you got these test statistics. So, okay, a two-tailed test, by the way, I want to focus on a couple of important ideas here. Your alternate hypothesis, you don't know what that is exactly yet in the context of a test, but that always tells you that you have a two-tailed test. I'm going to keep referring to that over and over again. And historically, ladies and gentlemen, you're going to have to find what's called critical values associated with your two-tailed test. Okay? And those critical values separate two very important regions. And I'll say, what are the regions? The do not reject the null region and the reject the null regions here. Okay? And I actually have them in blue, so I'll keep that in blue. So the tails, ladies and gentlemen, are really known as you're rejecting the null region, and the orange is a do not reject the null region. So we're going to test our hypotheses, ladies and gentlemen, with the two-tailed test this morning, and we're going to go through the procedure. You always are given what's called a level of significance. We're going to talk about that in a lot more detail. Like the confidence level we talked about, we know what the confidence level is. That's based on the arbitrarily large number of samples of a fixed sample size. That percentage will live between, the means will live, or the proportions live between those two values with that confidence level percentage. So this is actually related. It's the complement of the confidence level, but we're going to get through more detail here. Now, historically, this is all based on getting critical values. This is all based on, and I'll get back to that definition here. It is in your notes. If Elon Musk or Jeff Bezos buys them, they're going to buy this anyway, whatever. Okay? But historically, we use the Z table. You guys know we don't use that anymore. And historically, you actually had these, well, this is a two-tailed test. I won't go through that. It's in our notes. Historically, we had formulas to compute test statistics. And those formulas are found in this sheet as well. And I have them here. But now we're not going to use these formulas, ladies and gentlemen. We're going to use the what? The TI. So there's a lot that we bypass that you had in the past. And this here, the last page, is really how we're going to start this whole process. We're going to focus on, like I said today, a two-tailed test about a proportion. And these are the steps. We're going to go back to these steps. It's in your notes. This is that hypothesis setup that I talked about. So we're going to start the process today. All right? And then, yes, historically, this was our test statistic. You know, historically. It was a formula. That's it. It's a nice formula. And like I said, this is going to be your, it's really the scientific method. All right? And we're going to go through this nice process. Now, also on my website, I have notes on hypothesis testing about a what? About a proportion. That's where we're going to start. So if I go back here, I'm going to download the notes. I'm going to put that in the chat for people, for those who are at home with the bonbons. Anybody at home with bonbons? No? And I actually might start today on making my own examples to kind of keep it, I don't know, fresh, clean, and easy. What do you guys think? Should we try that out? Let me try this out for you guys, okay? Now, you guys know me. I like to use examples that students may find interesting. I think that keeps you awake. I think that keeps you interested. It's more likely that you're going to remember what to do because you like the setting, whatever, who knows, okay? So I always got to think of things that might be interesting to students. It might not be as easy as you guys think, so I always have to ask people. Don't know. What are kind of things you guys interested in? Anybody? You're college students. What are you guys interested in doing? Ooh, you want to go there? Or you want to think of some other, give some people a heart attack and anxiety, they got to go see their therapist?
How about Starbucks?
Starbucks? How about this? Let's create a nice, I'm thinking In-N-Out. You guys might like that better. Okay? The proportion of college students, this is going to be your first hypothesis testing question, who rate In-N-Out as the best lunch spot is, what? 35%, as claimed by what? Snodgrass. There you go. As claimed by Snodgrass. So I just want to kind of remark about yesterday. You might say, what does this have to do with yesterday? Does anybody have an idea? Yesterday, what did we do? We interpreted these hypotheses. You guys with me on that? So what does it say? The proportion of college students who rate In-N-Out as the best lunch spot is what? It's 35%. As what? Now, this is an extremely important detail. You might even say to me, what do you mean? Why is this an important detail? Because what they just did for you guys is this. They told you what the claim is. So when you translate that, as we did yesterday, P is what? 0.35. And then do this always. Always write this down. This is known as your what? As your claim, okay? This is the claim. This is an extremely important part that people overlook. Remember, language and what? Process. If you have any trouble with either of these, that could be an issue. Language. This is the claim. How do you guys know it's the claim? Because it tells you. And I always put that down. And who's making the claim, by the way?
Snodgrass.
Who's Snodgrass?
How if I know?
Exactly. We don't care. Somebody's making a claim. All right? Now, this is your hypothesis, ladies and gentlemen. This is the hypothesis we are going to what? Test. So the first step is to always do, I'm going to say step one. It's in the notes. Set up your what? Hypothesis. And you might say, well, what are you talking about to set this hypothesis up? Yeah. What you're going to need to do is you're going to have to write this down. You have what? Put your H naught and your H1. This is what I call the setup. This is where you start. You got to set up your hypothesis. You go, why is there two? Well, we'll talk about that. But if I ask you guys a question from yesterday, what does this have to do with yesterday? What kind of hypothesis is Snodgrass's claim? Is that a null or is that an alternate? No. Outstanding, it's a null. You guys know what you do? Put that claim in the null position. Because it's a null. How do you guys know it's a null?
Because it
Has a condition of what? Equality. All right, now, here's what you guys have to think about. That's really the statement you're going to test. That's the statement Snodgrass came up with. So I want to say to you guys this. What is the logical opposite of equal?
does not equal.
Okay, remember, equal has what's called a logical opposite. These have to be opposites. So either it is equal to 35% or it is what? Not equal. So those have to be logical opposites, these two. They're logical opposites. That's not equal. So this is your step one. You guys okay with that? Now, here's going to be step two. It's in the notes. You say, I want you guys to prove that. All right, it's in the notes. Where is it at here? Remember I put it all the way down here? See, step one is to set up the hypothesis. Step two, right in here, is you're going to create the decision rule associated with the null hypothesis being not equal. And that will always be a two-tailed test. This is step number 2. We're going to have to go over the details. You guys with me on that? This statement of not equal in the alternate position tells you this is a two-tailed test. It will always be a what? Two-tailed test. Because that's what people say. Hey, Mr. Judge, will that always be the case? Yes. When you have not equal for the alternate hypothesis. So draw your normal distribution. Draw your bell. And because this is two tails, because that's a not equal, you're going to need to draw two tails. Does that make some sense? All right, we have two tails here. Now, the truth is, ladies and gentlemen, well, we'll get back to that. This label, this region in the middle here, you always write as do not reject the null. And shade the two tails. These are known as the rejection regions. You reject the null. So your tails are rejecting the null. Reject the what? No. Do not reject the null. This is going to be a normal distribution, a z distribution. This is that standard normal. This is why you guys had the tables. This is step 2. And what you're going to need to find is the two critical values. And once we do that, your decision rule would be complete. However, you're going to have to focus on more information. You say, what more information? Here's what they're going to tell you now. I left it off. They're going to give you this statement. They're going to say use. You're going to have various statements here. Use the %5 level of significance to test this what? Claim. 5% level of significance to test this claim. So what they gave you is some very important information. And like I said, we're going to get back to that phrase like we did confidence level. But this is what's called alpha. This is that alpha we referred to. So all you guys need to know is this at the moment. But this is an extremely important definition. The level of significance alpha is the sum of the tails. It's the percent of the bell that's shaded in your what? Your tails. So if you have two tails, what does that mean? Anybody know? If you have two tails, alpha's 5%, what do they tell you? They just told you, ladies and gentlemen, 2.5% is in the left tail, and what? Is in the right tail. So I just want you guys to know that's half of alpha. Okay? This is going to be an extremely important detail. So they're always going to give you that phrase in black. They're going to give you a big important phrase here, okay? They're always going to do that? Yeah. They always give you a level of significance. Alpha is either going to be 5%, 10%, or 1%. In a two-tail test, half is in each tail. You guys okay with that? So what that means is, as a formula, if I go back to my notes, and I will, in my notes, this is why you see what you see there. Alpha over 2, alpha over 2. Okay, the level of significance is the sum of the tails there. Here it is. Here it is. We're going to find critical values. All right, so ladies and gentlemen, we're going to start off with that two-tail test with the procedure. And you might say, but how do I find that number? All right. How do we find the number? Now, I might have to go back to another set of notes. Where are you guys? I have described the procedure in your decision rule or how you find the critical values. So I'm going to bring this set of notes again. I have into the notability, create a new note, and I'm going to change that title to Fall 2023. Okay. We're going to import. Okay, here's what I'm getting at. How do you guys think we're going to find the critical values? What does it say? Okay, the procedure for getting critical values in that decision rule, you're going to use something you already have used. Inverse what? Norm. You might, I say you guys should be happy. Why are you guys happy? That's right. We're still in our decision rule. We got to get what's called the what? The critical values in the decision rule. So in that decision rule, we're not done. We need these red numbers. What are the critical values associated with the decision rule? That's going to be of vital importance for us. So let me share with you guys how you do it, right? You say, How? What do we have to use in the TI? Inverse what? Norm. Have you guys ever used inverse norm in your life? So you're going to go to your what? Second distribution. Where is inverse norm? It's the third one. It's the third what? One. How did you guys use inverse norm on the TI? Don't you have 95%? And then what? What's the mean for the Z distribution? Remember this? I'm telling you guys, this is going to be what distribution? This is the what? Standard normal. This is the Z. You guys know anything about that standard normal? Mu is what? 0. Sigma is 1. Always for the what? The Z distribution. So in your TI, you're now going to do what? You're going to go to what? You're going to go to the center. We'll show you guys if you don't have it, okay? Paste. This is inverse norm. You guys had a test on this. Go out to the nearest thousandths. What's this to the nearest thousandths? It's negative what?
1.960.
And?
1.960.
Yes, negative 1.960 and positive 1.960. So, ladies and gentlemen, these are your what? Those are your critical values. Now you have completed your decision rule.
Wait, where's the one from?
It depends what one you're talking about. The one in black there? It's because you're using what's called the standard normal distribution. The definition of standard normal is mu is 0, sigma is 1.
So it'll always be 0 and 1.
For the Z distribution, yes, yes, yes. So this is your decision rule, ladies and gentlemen. Most of the work is done. Most of your work is done. You now say, well, what do I do now? Well, step 3 is to take a what? A sample. So you're going to take a sample, but I'm going to say this to you guys, not really. You're not really going to take a sample. They're going to give you sample information. You go, really? That's nice. Yes. They're going to say this. A sample of 200 college students indicate that 38 rate in and out as, what did we say originally? As the best lunch spot. So, ladies and gentlemen, they're going to give you the sample information, okay? And what is the sample information? So this is just like what you did in estimation. You're going to read the sample information. How do you know it's going to be from a sample? It says it, and you're going to have to know, though, if they say a sample of 200, what does that mean? Your sample size is 200. What is X? X is what? 38. Easy peasy lemon squeezy?
What does it say? Step 3 sample.
Take a sample. Take a sample. Now, go back here. If you guys download my notes, hopefully you do. What does it say in step 3?
Take your sample.
There you go. Okay, you guys with me on that? What's step 4? Now, back in the day, your test statistic was this formula. That was back in the day. Guess what? You rented the TI for a reason. This is inverse norm, by the way. Two-tailed test. This is, guess what, ladies and gentlemen? Here's the deal. You're going to use in stat test 1 proportion what? Z-test. So you're going to use the TI to compute. Easy peasy. So if I said, you go to what now? Stat, test. Where is 1 proportion? 1 proportion Z-test? Is that number 5? Did you guys go back and watch the videos? Nobody? All right, I'm going to have to fill this in. But you might say to me, I don't even know what that is. What is P naught? All right. You guys know what X is. What is X? 38. Good. That's your successes. What is the sample size? Good. And then you see this next portion here. What are you guys looking at? It says the proportion not equal P naught. Use not equal. Let me go back and share with you guys why that's a not equal. If I go now back to the iPad, what kind of test was this in the iPad? Was that a two-tailed test? So this is a two-tailed test, okay? I want you guys to just remember that for a few seconds here. Remember that P naught? You might say, Mr. Judge, what is P naught? P naught is the proportion in the null hypothesis.
So is P naught like H naught?
Well, yeah, go back to H naught. What's H naught? That's the null hypothesis. P naught is right here. It's 0.35. It wants to know what that is. So this is 0.35. And I'm going to write that down next to my sample. And I'm going to even do this, just like we did for estimation. What is the TI command? 1 proportion Z what? Test. And when I use this, you might say, oh, proportion not equal, hit enter is a two-tailed test. I'll say that again. Not equal is a what? Two-tailed test. What is P naught? 0.35. So you are now ready, ladies and gentlemen, to hit calculate. So I want you guys to take a look at that. P naught is the proportion in the null hypothesis. X is your successes from the sample. N is the sample size. What is not equal? It says proportion not equal to P naught. What is that? Two-tailed test. Proportion not equal. I'm going to go back here. This is what they're talking about. Proportion not equal. It's a two-tailed what? Test. You guys okay with that? You're now ready. You say, what are you ready for? Tell me what step 4 is, because that's your test statistic. I usually put that in purple. It's going to give this is, I say TS. Let's see what the calculator says. When you hit calculate, it says what? Take a look, ladies and gentlemen. Line number 2. You know what line 2 is?
Z.
Go to the nearest thousands. That's your test statistic. What's the value?
Negative 4.744.
Negative 4.744. Is that what it is? This, ladies and gentlemen, is your what? That's your test statistic. I abbreviate that TS. This is what allows you not to use that formula. If you use the formula, this is what you'd get. So when I go back here in my notes, sorry. Okay, in my notes here, this is the formula. This is what we use the TI for, right in here. You know, we don't use that anymore. We use the TI. Oh my God. What's your last step?
State your conclusion.
State your conclusion. You guys know, here's going to be your conclusion here. You have only 2 conclusions you're going to give. Here's going to be your formal conclusion. You're either going to say one of 2 things. You're going to say this. Either the sample supports the claim, or what? The sample does not support the claim. You have only 2 conclusions. Your sample is going to support the claim. That's a good thing we have to label the claim. Either the sample supports the claim or the sample does not support the claim. This is a test based on a sample. So we got to know what the claim is. But more importantly, I just went through the details of this hypothesis testing procedure. We're not done, but this is the details in the $1 Million Notes. All right, all right. Maybe I'll win a Pulitzer Prize. What do you guys think? I don't know. All right, let's see what that last step is. What's your conclusion, step 5? Now, this is very easy. But some people have an issue. So we're going to have to go through it. You got to see, where does that test statistic live? That's a Z value. Where does that live on your decision rule? First of all, what number is that? Isn't that negative 4.744? You guys good with that? Okay. So where does that live? Well, first of all, it's to the left of 0 because it's negative. The question is it past your critical value? How do you know? Yeah. What was that test statistic? It's further to the left. Isn't it negative 4 point what? You guys with me on that? It is in what neighborhood?
Reject the H naught.
Yes. What neighborhood does that live in? No, it says to reject the what? No. You guys okay with that? To reject the what?
No.
Do you guys know what rejection is?
Every day.
Well, hopefully not. Hopefully not. That's going to break my heart. Do you know what rejection is? What is rejection? Push away. Has anybody here been rejected before in your life?
Yeah.
Oh, let's not go there.
You asked.
Do you guys know what I mean? I have to say it this way because people have to understand the meaning of rejection in language. We all have, I hate to say it, because even when I ask this question, there's always people, I've never been rejected as a judge. And I'll say, well, just wait longer. you'll be rejected, and maybe you were rejected twice or 3 times. What does rejection mean? We're rejecting the no. What does that mean? Here you are, no. Guess what, no? You're gone. Yeah. Goodbye, no. All right, this gets a little bit difficult to talk about. However, if you reject that no, what are you really doing? Accepting the alternate. Is that right? You guys with me on that? The no just got rejected, and that means your alternate is what? Accepted. So if you reject the no, goodbye, no, you're rejected. You're now accepting the alternate. However, what do we say your answers are going to either be? We said either the sample supports the claim or it doesn't. You go, Mr. Judge, what's with this rejection exception stuff? Is this a Jerry Springer show? Do you guys know what I mean? What is about this rejection stuff you're talking about? Okay. Here we go. Hypothesis testing procedure and hypothesis testing about a proportion. What do we happen to do to the claim? You know why we have to label the claim? Because we got to know if we're rejecting the claim. Did we reject the claim? Yes. We rejected the claim. That's why you always label the hypothesis. You label it claim. Wherever the claim, you label it. So if you're rejecting the claim, ladies and gentlemen, here's your conclusion. The sample, what? Does not support the what? Claim. There you go. The sample does not support the what? The claim. There it is, ladies and gentlemen. That's your first hypothesis testing question. It was what? Yeah, you guys are going to have to do some what? Some work. And you want to know what happens as you do more and more? It gets easier, gets easier, it gets easier. Then you can do it in your sleep. You guys don't know, I'm asleep right now. I never even woke up this morning. It gets easier and easier. Now, this is first we work on the mechanics of what you do. Then you go back and talk about what's called the level of significance, and then you're really looking at what's called the classical method. I always start with the classical method, and then you go on to what's called the modern method. But you got to follow a procedure. Now, this is the formal procedure in the scientific method. This is law, ladies and gentlemen. This is why this procedure is so important to get to and work through, because like the rest of the course is going to be based on these ideas. And this is so important about that. Do they talk about that in that class you have? That special class? Hypothesis testing, level of significance? They do? Yes, that's the modern method. And if you say, Mr. Judge, you never mentioned any of that. Well, we will. Your p-value, ladies and gentlemen, is that third line. It's p. That's close to 0. If the no, huh? Well, yes, because what's so important about the 0.5? See, this is a probability. If the probability is close to 0, that means it's not likely. The 5% is the threshold. It's the level of significance. Now you can change it to 10% or 1%, but 5%, we've always said, remember how I've always prepped you guys? Not likely, like a robot. Oh, look at this percent. It's because of this. Mr. Judge is on the ball. And he has worksheets called the modern method too. Ooh, you guys are in for a treat, ladies and gentlemen. I'm excited. I'm excited for you guys. I'm like, man, I can't believe they pay me to do this. I would do it for free.
Careful, they may say that.
Yeah, tell me about it. Well, that's why you guys have the website with these notes. Nobody's paid me. You kidding me? There are people, I'm not going to mention, there are faculty who won't do anything, huh? They won't do anything unless you pay them extra. I do not like that. I'm like, are you serious? I hate that. I don't know. Whatever. No big deal. So there it is. You're going to see more. You're going to see the modern method, p-value method, and but we first start with the classical method, and after you guys get that experience, we move on to the p-value, and it's good stuff. It's really good stuff. So this really is, like I said, I'll write this stuff for free, and I have. So anyway, nobody gives me the cookies, but that's okay. I'll get into what, and that's all that matters. I'll get into heaven. Hopefully. You guys pray? No. Then you pray that I get into heaven. You pray for me. Say, let's make Mr. Judge strong. He's got to get back to working out and stuff. Make him healthy, strong, happy, and get into heaven while you're at it. You guys ready to try it again? Let's try it again, because you guys have to get more practice. And practice makes what? Perfect. Okay. Ooh, I might even bring it up. You guys may not. Maybe we should stay away from religion, right? And praying, because some of you guys are going to get angry. You like In and Out. What else can we say about a proportion? Huh? Chick-fil-A? You guys like food? All right. You want to do a Chick-fil-A version? Okay. What's for lunch?
Spicy grilled chicken sandwich.
From Chick-fil-A?
Why not?
Do they have a spicy grilled? Oh, they used to? What happened? Chicken what?
It's like
Biscuits and chicken?
it's like a mini slider.
For breakfast? Oh my God. The breakfasts are good there? Really?
They even have like a scramble with like hash browns and
hash brown, eggs, and
you could put it in a burrito or have it just like
the burritos.
and then for breakfast you could do like a side of yogurt and fruit or just fruit or hash browns.
Mm.
Pretty good. I just know like the burger.
All right, well, maybe I'll stop by Chick-fil-A. Can Uber deliver to your office?
Yeah.
Yeah. You just
They
gotta
do?
Get them to a drop-off location.
You would probably have to pick it up in the parking lot.
I'd have to go out there. I want them to go to my office.
You have to go into the public.
No, you could ask.
You could put
Like
like
if you type in the notes.
Oh, yeah.
like
Like when they might, like I know when you order through Yelp or DoorDash, like I work on the third floor of a building, people order food and they bring it up.
Yeah. I just wonder if they're going to go to what? I don't even know my office. What?
This building?
Yeah.
I used to
Isn't
get
this
them
like
to drop
G5
it
or
off at my
something?
aunt's
G5
office
with like the
in
number.
high school.
Yeah.
I say, hey, go to G5 111J.
They're gonna get lost and they're gonna give some random person your food.
Yeah, exactly. Well, I might just pick up Shakey's. How's that? You guys don't like Shakey's?
I like the Mojo.
I like Shakey's. I do agree. I like Shakey's pizza.
Yeah, it's a little too early for that.
You might be, but I agree with you guys. My wife disagrees. We always argue and fight. She doesn't like Shakey's. I like Shakey's.
Like I'll eat the chicken and Mojo's, not the pizza.
Oh, you don't like the pizza? I like the
Too
pizza.
basic.
Oh, it has a little spicy kick. I like that tangy sauce and the.
If that's spicy,
love it. It has a little kick. It's tangy.
You make some jalapenos.
You guys don't like this pizza at Shakey's? Yeah, I do. Oh, my Lord. Never mind. Chuck E. Cheese. I once, all right, I'll tell you, years ago, this was a long time ago, I taught at a middle school. And I remember I promised the period that behaved the best for the month, I was going to give them a pizza party. And I'm like, okay, so, and so I did that. And at the end of the month, okay, period 5. I don't remember what period, maybe not 5, but who knows. I said, okay, you guys want the pizza party? And they're like, yay, okay. Now, I was going to treat these kids right. I was going to give them some good pizza. There's a couple of good pizza places around. This was out in, I taught at Al Sereno Middle School. And I was going to get some pizza around Alhambra. Is that your middle school? Yeah. Charlie's Trio. There you go. I was going to get some good pizza. You know what they told me they wanted?
Chuck E. Cheese.
Mm-mm.
Little Caesars.
No.
Domino.
Papa John's.
Pizza Loca. And I'm like, are you guys serious? It's not even real cheese.
Dude, I'd rather go
Okay, we have to think about the area and like the pizza they grew up on.
They insisted. That was a learning experience for me. They insisted on Pizza Loca. That was for them the ultimate pizza experience.
That one I can go to 13.
Oh, they're children. They have no taste buds.
As long as
I
it's
know.
not Chuck E. Cheese. I used to watch this YouTuber. He worked at Chuck E. Cheese, and he said one time he cut his hand open and he bled on the pizza, and they still gave it to him. And ever since then, I've been so grossed out.
It's like recycled or something. Hey, that's what you be eating, girl.
How do you spell Chick-fil-A?
CHIC-FIL-A.
Ah, whatever. Chick-fil-A. Chick-fil-A. How do you spell that? Chick-fil-A. Chick-fil-A.
Chick-fil-A.
Filla? It's Chick-fil-A.
This is what's it called?
It's Chick-fil-A. It's Chick-fil-A. That's what online Chick-fil-A. Hey, the proportionate center for Chick-fil-A for lunch is not 12%. Use the 10%. Oh, sorry. Here's how they really do it. They'll say a sample of 50 college students reveal that 8 prefer Chick-fil-A for lunch. And then they'll say use the 10% level of what? Significance to test this claim. Now, this is a classic kind of question to ask. This is how they word everything, ladies and gentlemen. They word it this way. So you're going to need to do what? Read it and translate what's going on. And I'll help you with this because they're going to say what? The what? The proportion of students who prefer Chick-fil-A for lunch, what are they saying? Is not what? 12%. Oops. And then we forgot. You know what we forgot? We forgot the statement. As claimed By who?
Snodgrass.
Snodgrass. Good old Snodgrass. So once you read that, ladies and gentlemen, you know what you want to think of again? Say, this again is the what? That's the claim. Good old Snodgrass. So you're going to put P now. What is not? It's not equal. P, not equal to 12%, the decimal, and you're going to say this is the what? Claim. Okay, so far so good. Now, what do you guys do? The first step is always to do what? Set up your hypotheses. So you do that first. This is a hypothesis setup. Always, always what? Always. So, ladies and gentlemen, I have to ask you, where do you place this claim? Is it a null or is it an alternate? Do you put it on top or on bottom? Null or alternate? Null or alternate? It's an alternate hypothesis, okay? You guys okay with that? Why is it an alternate? Does not equal. Good. What's the logical opposite to that statement of not equal is what? Is equal. So I want to share with you guys something extremely important. This is where some students go get wrong from the start. They assume that every claim must be a null. And it's not. This is Snodgrass's claim. Snodgrass says the proportion is not 12%. So you can say is, you can say is not. So my point is, here's an example where the what? The claim is an alternate. And what always determines whether this is a two-tailed test? Right here in purple. If you ever see not equal there, this will always be a what? Two-tail what? Test. Always, always what? Always. Did we say always? So now you guys have to set up your what? Decision rule. Draw two tails. One tail, what? Two tails here, okay? Make sure you label your regions, okay? What is the middle always going to be? It's going to be a what? Do not what? Reject your null. And then this region will be the what? Reject your null. This will be what? Reject the null. You need these things known as what? You need the critical values. Does anybody know what's your level of significance? What did they say? They want you to do what again? Use a 10% level of significance. Is that right? They told you a level of significance. That means alpha is 10%. But for two tails,
Can you just say where you got the 10% one more time?
10%,
Yeah.
they told me. What did they say?
Oh, yeah.
They will always tell you. They will always tell you alpha. They'll say use the 10%, 5%, 1%. And if it's two tails, half is in each what?
Tail.
Tail. Okay, see that there? 5%, 5%. Now, why do you guys think it's important to know that? Because when you use what? When you try to find these critical values right here, what key do you use? Inverse what? Norm. You got to use inverse norm in your calculator. So you're going to go now again, stat, distribution. Inverse norm is number 3 now. And you might say, Mr. Judge, what does that mean? Can I do 5% area to the left? Some of you guys said, what about the default? I'm feeling a little left out. We didn't talk about that. So if you have the other calculator, do you guys remember on your test? Didn't you use the default? The default was the area to the left of the critical value, and that's 5%. So if you have the other calculator in honor of those, put 5% area to the left. What do you get? Let's go to the thousands. What is that critical value going to be? What does that say? Negative 1.64 what? 5. So, ladies and gentlemen, that's one critical value. What's the other? Positive 1.645. So, you didn't ask that question, or you actually did. We never answered it. But if you have the default, ladies and gentlemen, it's area to the what again? Area to the left. You guys with me on that? That's how you use inverse norm to get your critical what? Values. We're almost there. Almost there. Yes.
So, because it said that the level of significance is 10%, you're just dividing the 10 from 5 on that. From the
5 and 5, yeah.
So
Good.
if it was a level of significance of 20%, we could do 10.
10 and 10. Yep. Absolutely. You guys see, it'll get easier as you go along. We just have to read now. What does it say? Sample of 50 students reveal what? 8. So N is 50. What is X? X is 8. So when you write down your sample information, N is 50. What is X? 8. Remember, you need P naught now. And what in the world is P naught? Remember this? P naught is right here, ladies and gentlemen. 12% is P naught. %12 is P naught. You're going to use what in the TI? 1 proportion Z what? Test. This is a hypothesis test. Okay, you guys okay with that? Practice makes what? Perfect. So, stat, test. Where was 1 proportion Z test? Is that number 5? Okay. What's P naught? 12%. What's the number of successes? 8. What's the sample size? 50. This is a two-tailed test. Is that true? Hit now what? Calculate. So, ladies and gentlemen, that's all the information you punch in the TI. This is a TI game. What's the test statistic? Remember, your test statistic is that Z value. It's 0.870 to the thousandths. Is that true? That's your test statistic. Just want to let you guys know. They're going to ask you for that. So what do you do with that number? Where does it live on your decision rule? 0.870. Anybody know? 0.87. Is it 0.870? That's not quite 1, right? It's positive, so it lives to the right. Is it past? Is it past the critical value? No. Your test statistic is maybe right here, 0.870. Okay? What neighborhood is that in? Do not what? Any test statistic that's between these two numbers, that's between your critical values, ladies and gentlemen, you do not reject the null. You don't reject it. So we have to know, hopefully you guys know what this feels like. What does it feel like to not be rejected? Anybody know what it feels like? I'm going to hug my null. You want to know why I just hugged the null? Yes. You guys know what that feels like? Not to be rejected? If you're not rejected, aren't you accepted? What does that mean about the claim? You're going to not reject the null. You're going to accept the null, but that happens to mean that the alternate is out. What is out? The claim. What does that mean, ladies and gentlemen?
That the claim is false.
The sample what? Does not support the claim. There's two answers. Either the sample supports the claim, or the sample what? Does not support the claim. There's your conclusion. So, ladies and gentlemen, that's the hardest part for some. They're not going to be sure about some of those phrases. So, to not be rejected means you're accepted, but the other guy is out. You only can have one, ladies. If you're not going to reject Mr. H naught, you're not rejecting H naught, you are accepting H naught. Guess what you got to tell H1 to do? Take a hike. That's why I canceled it. That just happens to be, we told the claim to what? Take a hike. So you know what? You get to go back to Snodgrass. What is Snodgrass saying? The proportion is not 12%, but yet the sample is suggesting that the proportion actually what? Is 12%. And that's another hypothesis testing question, ladies and gentlemen. Easy peasy, lemon squeezy. What do you think? Classical method. All right, ladies and gentlemen. So let me do this here. Let's go take a look here online because I do have hypothesis testing about a proportion worksheet. So assignment number 4. Yeah. You guys remember what our next test is?
Yeah.
It's like December 4th or something. Is that right? Or what time does your class start?
Yeah.
All right, ladies and gentlemen, there you guys go. We'll do some more tomorrow. Take care, stay safe, have a wonderful day. That you guys care about, okay? Do a nice little warm-up question for you guys as we proceed, okay? See if you learned anything yesterday. All right, let's stick to the topic. The proportion of college students who have experienced what we call night terrors, whatever that is anybody have a night terror? Just curious. Or how about no? Let me go back. Not a night terror. Sleep paralysis. Okay. That's why I'm giving it to you guys. Not because it's scary, but because you can relate to it. Or I can talk about widgets and you don't even know what widgets are. Nobody knows what widgets are. That's a general term. So have experienced sleep paralysis. Is, let's say, what should we say? 22%. How's that? As claimed by good old what? Snodgrass. Okay, I'm going to say now this. A sample of 250 college students reveal that 55 have experienced sleep paralysis. Use the 10% level of significance to do what? Test this claim. Test the claim, test this claim, whatever. So we're going to go through again an example of a two-tailed test. It's a hypothesis test about a proportion, and we're going to try to see what that is and how that works. And ladies and gentlemen, there you go. Okay? But we didn't do, remember, typically you're going to see a 1% level of significance test, a 10%, or a 5%, typically. You know, the basic default is 5%, though. But there's others, so I just want to talk about that, too. You know, like an industry standard looking at 5%. But you could do a little better. They could go down to 1%, you know. So here's what I want to say. I'm going to say this to you guys here, right? I think I'll help you guys out with this one. The proportion of college students who have experienced sleep paralysis is 22%, okay? Oops. As what? Claimed by who? Good old Snodgrass. So when you read that, what do you guys want to do? What do you guys want to write down? P equals what? 0.22. And make sure you always write down the word what? Claim. If you don't, you're going to get lost. Wasn't that the first thing we always did, ladies and gentlemen? So focus on this portion here, okay? Because now you're going to do the first step, and you might say, hey, where are the steps again? Well, I'm not going to go to my website, but this was that hypothesis testing procedure, right? The 5-step procedure right up here that we talked about yesterday. So your procedure is there, and the first step is going to be to set up your what? Hypothesis. Yeah. You go, what's the setup? H naught, H1. So where, ladies and gentlemen, do you put the claim?
H naught,
Why?
because it has a thing of equal.
Has a condition of equality. That's the definition of what we call a null hypothesis. So you guys want to start by putting the claim in its proper position. Does that make sense? All right, good. Now remember this. This is ultimately really what you're testing, but you're going to have to indicate the logical opposite of the proportion equal to 22. What's the opposite of that statement, the logical opposite? Proportion is not equal to what? 0.22. You guys okay? So one of these statements are going to be rejected, and one of these statements is going to be accepted, is what's going on. All right? It's like two candidates. One is accepted, the other is rejected. You with me on that? All right. Now, this is the hypothesis setup. Step 1. Step 2, ladies and gentlemen, is your decision rule. So bring out your bell, bring out the normal distribution. And again, it's the standard normal. It's Z, standard normal. And you guys remember from yesterday, the standard normal always has what? The mean is 0. Good. Standard normal Z distribution here. Okay? Now, how many tails is this test?
2 tails.
How do you guys know it's 2 tails? Right there, the not equal and the alternate hypothesis, right here, will tell you that this is going to be a 2-tail test. So draw 2 tails. Left, what else? Right. And you're going to shade your tails. Okay. What goes in the middle? Always. You guys have to know this format. You're going to always put in the middle, do not what? Do not reject the null hypothesis. Always. What goes in your tails? You're gonna those are called the rejection regions. Reject the null. You're going to reject. Those are your rejection regions, ladies and gentlemen. Reject, reject, reject. Now, you got to read further, and you got to read all the way down to what it says is the level of what? So you're going to use the 10% level of significance. You say, what does that mean? It means your alpha is 10%. We're going to talk about alpha in specifics, but you guys know from yesterday, we're going to see what this alpha, this level of significance, we're going to have a discussion about it. But that 10% low significance, where does that go? Well, half of alpha is in the what? The left tail. What's half of 10%? 5% in the left tail. The right is also 5%. So I'm going to kind of have to do this here because there's not space. Now, the reason we need to know this is because you got to find your critical values. Okay? These are known as CV critical values. You got to find those numbers here. Without them, you can't even proceed. Without them, you don't even have a decision rule. And if you guys remember from yesterday, okay, how do we find critical values? Back in the day, you'd use your Z table. Does anybody want to tell me? I'm going to focus today. I'm going to use the bad calculator in the TI. I'm going to use the default because some of you guys have the default. Is that true? So for those of you guys with the default, here's what I'm going to do for you guys today. I'm going to switch over to the other one. And I'm going to show you guys again how you use this here to get the critical values, okay? Now, do you guys remember the default on your task, working backwards? Because you're going to use inverse norm. Is that true? Inverse norm, you need area to the left of that critical value. This is area to the left. So if I ask you, what is area to the left of your critical value? What's in that left tail?
5%.
And how do you write 5%?
0.0.
Outstanding. Look at that, ladies and gentlemen. Okay. So let's use that default. And you go, okay, inverse norm is under where? Second vars, which is really your distribution list, and inverse norm is number 3, okay? It just says area. They should put area to the left, so it's 0.0 what? 5. You guys okay with that? This is the Z distribution, so the mean is 0. The standard deviation is 1. We got to change that. And what this is going to do is it's going to give us our critical value, ladies and gentlemen. And that critical value to the thousandths will be what? Negative 1.645. So you're going to do this. That is your critical value, okay? And then now you say, but what's the other one? I have 2. Well, your Z distribution is nice and symmetric. What does that mean again? What you see on the left is the same as what you see on the right. Think of being beautiful. A face that's symmetric is one that, well, you guys remember. 1.645, and make that positive, okay? Symmetry, ladies and gentlemen, is the artist's definition of beauty. It's a face that's symmetric, so I want you guys to know that. Both my parents are artists. This is where I learned it. Okay? Easy peasy lemon squeezy. Do you guys know what this is called, by the way? Step 2 is your decision rule. So I'm going to go back here. Oh, that's not you guys. That's calculus. Step 1. Oh, that's step 2. I don't. Did I? Oh, typo. So we've done the setup, and we've done the decision rule, and we did label our what? Hypothesis as the claim. We did label it. That is what you just did. The first 2. That's kind of like most of the work. You say, what's the rest of the work? Take your sample, compute the test statistic, and state your conclusion. Oops. Sorry. Sorry, this is people who... Oh, I'm sorry. We're not in the website. We're on the iPad. Okay. So remember, you don't really take a sample, do you? What do you really do? You guys know what you do? You read what they gave you. You say, what did they say? A sample of what?
250 college students.
Reveal that
55.
55 have experienced sleep paralysis. That's when you're paralyzed in the middle of the night because you're scared. I don't know. What is N?
250.
What is X?
55.
There you go. So the sample size will be what? And X is what? Don't forget from yesterday, we need that P naught from yesterday. What is P naught again? It's the proportion in the null hypothesis. So you go, well, where is that? That's right over here. This is my P naught. It is 0.22. So you're going to write that down, 0.22. And I might just remind everybody that this is a what again? Two-tailed test. How do you guys know it's a two-tailed test? Right in here. H1 is not equal. Not equal is always a two-tail. All right. So now, ladies and gentlemen, you got everything you need now in the TI. You got everything you need to compute the test statistics. So this is like step number 3. Take your sample, but in reality, we're reading the sample information. And then computing the test statistic. What do you guys use in the TI? What's it called?
One proportion z-test.
Yep. Easy peasy, lemon squeezy. We're going to use that Z here. We're going to the thousands again, right? Let's see. Stat test. Where's one proportion Z test? Number what here?
5.
Is that number 5? All right, write that down. Okay. What's P naught? 0.22. What is X? What's N? Good job. Okay, is this a two-tailed test? So leave it on not equal. Is that right? That's proportion not equal to. That's actually, that is actually, ladies and gentlemen, what is that? That's actually the null hypothesis, by the way. P not equal to 0.22. So that's a two-tailed test. Now do this. Hit enter. And wow, that's amazing. What is the Z value? 0? Did we do everything correct? Z is equal to what? 0. So it means Z is 0. I don't think I've ever done anything like that to the nearest thousands. All right. This is called your what? This is the test statistic, ladies and gentlemen. Let me go back to the calculator. Ah, you know why? The sample proportion is exactly 22%. You see that P with that hat? That's why. The sample proportion is the same as the true proportion. Okay. So, all right, that makes this nice and easy. This is the test statistic. What are you really looking for again? Any test statistic that lives between your critical values. What do you do?
If it lives between them, then you accept it?
Well, what does that say? Any test statistic that will live between your two critical values here. You do not reject the null. What does it mean not to be rejected? You're accepted. Don't you guys like that? You're not rejected. You are what? accepted. What does that mean about the claim? You accepted the claim. Is that true? What does that say?
P equals 0.2.
Yeah, the true proportion is in fact 22%. But what's our two conclusions? Remember this? I said there's only two possible answers. You're either going to say what? The sample supports the claim, or the sample does not support the claim. So what is our conclusion? The sample what? Supports the claim, ladies and gentlemen. Here's the conclusion. Easy peasy, lemon what? Squeezy. So, ladies and gentlemen, that was kind of an interesting kind of a situation. Your test statistics never is really zero, but okay. But that's fine. What do you guys think? Isn't that what we did yesterday? All right, now you might say, well, we did that yesterday. Let's look at the different tests that we have. We have what's called, ladies and gentlemen, this was a two-tailed test. We have what's known as a right tail and a left tail test. So it's not just two-tailed tests. You can have a right tail test. And in which case, if you said, what if I have a right tail? Well, where's your tail going to be then? To the right. You guys okay with that? And if your tail's to the right, all of alpha is in that tail. There's no splitting it in half. If it's a left tail test, where is alpha now?
In the left hand.
And all of alpha is in the left there. Easy peasy lemon squeezy? All right. Well, here's the deal. How do we determine whether it's a right tail or a left tail test? Yes, it depends on your hypothesis.
Is it
However, what do we say you always look at?
inequality signs?
See this? See the alternate hypothesis? When it's not equal, it's a two-tail test. When the alternate hypothesis is greater than, what direction is that pointing?
To the right.
Is that pointing to the right? It's going to be a what?
Right tail.
Right tail test. If the alternate hypothesis is pointing to the what? Left. What is it?
Left tail.
It's a left tail test. Easy peasy lemon squeezy. So let's look at an example here, okay? College student example. I don't know what to say. The proportion of college students who do what? What do you guys do?
Drink coffee.
Drink coffee? Every morning. Oh, let's say drink coffee before a test. Is more than 28%. Okay? A sample of 120 college students revealed that 40 drink coffee before a test. Okay? I'm going to say now use the 5% level of significance to test this what? Claim. Easy peasy lemon squeezy? Well, let's see. So this is done exactly like what we've been working on, okay? It's not that hard. You do got to go through the process. You got to do it over and over again until you can do it in your sleep, which means you got to do your homework ASAP now. It doesn't mean you wait till the night before. You do that, it's over. It's done. And I think I forgot something. Okay. You guys might be able to figure out what I forgot because I'm going to write it here. Yeah, good old what? Good old Snodgrass making their claims. Okay, so I'm going to say here. As what? As claimed by Snodgrass. Good old Snodgrass. More than what? 20%. 20% as claimed by what? Snodgrass. Proportion P. So the reason I want to emphasize that is because it's very important to know what the claim is. Because you could never draw your conclusion if you don't even know what the claim is. And that's the idea, okay? So the proportion to drink coffee before a test is more than. How do you describe more than? Anybody remember this? You've been seeing these phrases forever. Did you guys get the language down? What does more than mean? Strictly greater than. Good. Greater than 28%. So that's greater than, and 28% is 0.28. And this is the what? Claim. Okay? You need to write that down. Without it, I don't know what to say. So when you set up the hypothesis again, what do you guys do? Yeah, you got to find out. You go, okay, where does that belong? Is that a null or is that an alternate? It's an alternate. Is that true? How do you guys know it's an alternate hypothesis? It lacks the condition of equality. Go back to those notes. There's no equality. That makes it an alternate. Do you guys remember? Now, what is the logical opposite of greater than? Do you guys know what that's going to be? Well, be careful. It's not just less than. It's less than or equal. Yeah. So the logical opposite of greater than is less than or equal. I'm going to say that again. The logical opposite of the greater than sign is not just less than. You must include the what? The equal to as well.
If we had it flipped and the claim was, for this example, greater than or equal to, then the opposite would be
Strictly less than. Yep. So let that sink in. Don't forget about the equal. And doesn't that make sense that that would be a null hypothesis because it has a condition of equality? You guys okay with that? All right, ladies and gentlemen, here we go. You guys ready? Let me ask you guys again. That's setting up the hypothesis. That's always your first step. And then now you do the decision rule. Say, what's my decision rule? Let's ask you guys. Is this a two-tailed test? How do you know it's not? You always look at the alternate hypothesis, and what you see here, ladies and gentlemen, is an inequality sign that points in what direction? To the right. What does that mean? It's a right tail test. So for any right tail test, all of alpha is in the tail. But what is alpha anyway? Use the 5% level of significance. Alpha is 5%. That goes in this what? Tail. 0.05. This is where all of your alpha belongs. Now, we're going to have to label the regions again, right? So, what's the non-shaded region labeled as? Do not what? Reject the null. And what's this one called? Reject the null. So I'm going to have to move these things. And you need a critical value, don't you? What do you guys think? Now, you might say to me, okay, I see your point. We're not done with the decision rule because what do you guys need?
Critical value.
Yeah, we need the critical value. And in fact, on your test, I'm going to ask you, hey, what's the critical value? I'm going to ask you, what's the claim? I'm going to ask you, what's your critical value? So in this case, there's only one. A two-tailed test always has two critical values. So you're going to have to use your inverse norm key. Is that true? But it depends on your calculator. What if you have that older calculator that uses the default? Remember I said we have that default version here? Area to the left of the critical value. What is the area to the left of the critical value? Good job. Thank you. Thank you so much. The complement of 5% is what? Is 95%. Is that true? You guys know what I'm saying? If 5% is in the tail, right in here, the complement is 95. So in the calculator now, when you go to second distribution inverse norm now, you got to put point what? 95. Same mean, same standard deviation, mu is 0, sigma 1. Ladies and gentlemen, what is this? It is 1.645. Yeah.
So for the rest of us that don't know that calculator, for the tail, would that be considered left or center?
Okay, good question. Now, what we're going to do now is this. I'm going to change that calculator to accommodate the students that have spent a little bit more money, or maybe you got the other one, right? Maybe you rented it. Second distribution, inverse norm. Here's what I would do. I'm going to keep it as 5%, but where is 5%? Is it on the left? No. Is it in the center? No. Where is your 5%? Isn't it on the right, ladies and gentlemen? You guys see what I'm saying? I'm going to use that. So I'm going to put it on the right. Hit enter. And notice you get the same answer. So if you have that other calculator, put the 5% right tail. Yes?
And this is only when it holds right or left first,
That's correct.
and when it's a two-tailed test, we would just do, well,
If it's a two-tailed test,
the level of significance of 10%, we just put 0.5.
well, be careful. A two-tailed test, there's more to the story. Be careful. Two-tail test has 5% in each tail, yes. But what calculator do you have? Do you have the default? Then it would be 5% as a default. But if you have this calculator, you'd have to choose 5% on the left, on the right. You make that choice.
I just have like the regular one where I have to actually like put 90.95% if it wasn't right.
Okay. So, ladies and gentlemen, there you go. You guys remember, the devil's in the details. You got to know your calculator.
The point one.
Where is it? Is it 0.1? I don't see a 0.1 anywhere.
No, like when you're putting in the calculator, I guess you put like in the numbers right here. And the
Oh, mu is 0. Standard deviation is 1 because you're working with what? The standard normal. This is a standard normal distribution.
and mu is 0.
Mu is 0. Sigma is 1. Standard normal. So let me write that down in case you guys don't have that. What is mu? Sigma 1. This is the standard normal distribution. Okay? So it depends on your what? Calculator. You got to know your calculator. How do you get to know it? Using it. Good answer. If you don't use it, you're never going to know it. When you go to sleep tonight, what do you put under your pillow? Your calculator. I'm serious. You get to know it. It's always in your hand kind of thing. If you do that, it'll be a good thing for you. Yeah, I know. Okay, now, what does it say? A sample of what? 120 reveal that 400 what? Or 40. So you're going to have to know what that means, right? What does it mean to have a sample of 120? That's N, your sample size. What does the 40 represent? X, your successes. So, ladies and gentlemen, write that down because your sample now is what? What's the sample size?
120.
What's the number of successes?
40.
And then never forget, you got to use the P naught. What's P naught?
0.2.
P naught is always right here. It's that P in the null hypothesis. Could you say, what is P? Less than or equal, so P naught equals 0.28. Okay? And don't forget, what kind of test is this?
The right tail test.
Right tail. What do you use in the TI?
1 proportion z test.
I would say write that down. 1 proportion Z test, because this will help you remember if you write it down. But do this all like now. Every day you do some work, right? You work on this kind of stuff. And so now in the calculator, you say stat test. What's 1 proportion Z test? Is that 5? Okay. P naught. 0.28. What is X?
40.
What is N?
120.
What kind of test is this?
Right tail test.
Find the inequality that points to the right. Where is it?
On the right hand side.
Is that it right there? The last one? Okay, we're good, ladies and gentlemen. Hit what?
Calculate.
Calculate, and the Z value to the thousandths, that's your test statistic. So I'm going to ask, what is the test statistic? What is it?
1.301.
That is the test statistic. This is where we have to see where it lives on your decision rule. Test what? Statistic. So where does that even live? You go, oh, you know where that lives? Is it past the critical value? No, it's before, right? Isn't that before the test statistic somewhere? So here's how this works again. The reason you care about your critical value is because any test statistic that lives to the left of the critical value. Okay? Let me try to draw an arrow if it lets me. What neighborhood is that in? Do not reject the what? The no. Do not reject. What does not rejecting really mean? You are what? Accepting. So do not reject the no. You're accepting the no. Okay? Take a look at this. A picture's worth 1,000 words. Do not reject the no. It means you're accepting the no. However, what does that mean about the claim? That means the claim is what? Out. Why is the claim out? The claim is where? The claim is in the alternate hypothesis position. So, not rejecting the no means you accept the no, and the statement is that the proportion is no more than 28%. It's less than or equal. What's your final conclusion? What do you guys have to write down? The sample does not support the claim. Good job. So, ladies and gentlemen, this is the conclusion that you give in red, because like we said, either you say the sample supports the claim, or the sample what? Does not support the claim. Those are your two conclusions. So this hypothesis test says the sample does not support what Snodgrass is what? Is claiming. And this is a right tail test. All right, you guys okay with that? And that's kind of the deal right here. So that's your first experience with a right tail. Well, we'll see. I think I did give one, but I have given you one. But one of them, I have seen it. You like supporting the claim? Well, let's ask you some questions first. What do you care about? What do you care about? Because you got to give an example. What do you care about? Your sleep. Are you a teenager, by the way? Didn't I give you guys that teenage example? I used to sleep for like 10 hours and my dad would get mad. Those parents. Do your parents get mad if you sleep a lot?
Mom doesn't like when I sleep at all in general.
She doesn't like when you sleep.
No, she'd rather me be at work.
She'd rather you be at work?
She doesn't want me in the house.
Why not?
I don't know, she just doesn't want she'd rather have me at work.
Oh, I don't believe that. She comes out and says, I'd rather see you at work.
I had the day off one time and she's like, why are you home?
Okay. Mom, why are you home? Let me think of my dad. Maybe he would be like that too. And you're a teenager, right?
It's because, like, my mom, like, when she was a teenager, she was always working.
Yeah.
So, like, when I'm home, she just finds it weird.
Yeah. I know my dad used to, he used to lecture me as a dad, and, he used to say he always worked. Hardworking man. But you want to know something before he passed away? You know what he said to me? He said, you know what, Daniel? I feel really bad because he felt like all I taught you and your brothers and your sister to do is work. Because we all work very hard. Me, my brothers, my sister. He felt bad about that. He says, all I did was show you guys how to work. Interesting. So maybe one day, maybe 10 years from now, maybe 20, your mom might say, you know what? Don't work so much. I predict that. That's what I predict. So let's write a question here. The proportion of teenagers who work after school is, what should we say? 15%, as claimed by who? Good old Snodgrass. Boy. Snodgrass is making a whole bunch of claims. Okay. A sample of 200. Have we used 200 before? We'll say 300 college students. I apologize. I'm going to have to do something here. Is what? Is less than 15%. Okay, as claimed by good old Snodgrass. A sample of 300 college students reveal that 28 work after school. Use the 10% level of significance to test this claim. Alrighty. Here we go. Proportion of teenagers who work after school is what? Less than. I'm going to give you guys a little bit of information here, okay? And this is be as claimed by what? Snodgrass. Now, I do know there's a certain reality that people have, and I think it's great. Is anybody here in high school, by the way, you worked after school? Just curious, just since we're on the topic. How many of you guys worked after school? One, raise your hands high and proud. Okay, you guys worked. Okay. Did you guys know there is data and research? I'm not against work, as you guys know that. I came from a family that works hard, so I'm not against work. But there is, I'm trying to remember some data and research about teenagers who work. I think teenagers who work, like in high school, they're more likely to do things like what? Drink, smoke, what else? Do adult things, I guess. Do you guys know what I'm saying? So there's research out there that suggests, hey, your teenager's working after school, it's great. And I always wanted to work as a teenager because I know my parents wouldn't buy me anything. So it's like, I'm going to work, I'll buy it for myself. You guys know? And they never let me work after school as a teenager. And I just remember some of the research on that. Like, hey, did you know teenagers who work after school, they're more likely to be like delinquent even and all kinds of stuff. I wonder why. Notice the phrase I use, more likely. What is that? Does that mean it's a guarantee? No, you're saying, Mr. Judge, I worked after school. I never drank a single thing. I never smoked anything. I always behaved myself. You know, maybe that's the case, but this is probability. Okay, you see what I'm saying? It doesn't mean that it's certain. This is using the language and the ideas in a way that's meaningful, and that's what the course is about. So I just want to ask you guys, anybody here, those after-school kids, you went working, is there any truth to that statement? No? Nope. Those workers never try to encourage you to go have a little drink after?
All my coworkers were adults. If they were inviting me to go hang out, that'd be a little weird.
Well, it happens. I just want to say it can happen. Maybe it depends on even where you work. Maybe it depends on even what you do. I know when I worked, my coworkers would try to entice me with alcohol. I can't tell you where I work, but okay, I'll tell you. Bank of America. Bank of America. It was great. I loved it. I recommend it. Yeah. It was more pay than minimum wage. I was making good money as a kid. You kidding me? Tell me about it. I highly recommend it. And then during lunch, I was a teller. You know how I got my teller job? They gave me I'll tell you, it's a true story. You're going to cry though. Me and my aunt, we found out that B of A was hiring. I don't forget how we found out, but somebody told us. So we went down to file an application. Me and my aunt, she's like my sister. She's like a year older than me. So I was like 17 or 18, and she was like 19. You guys know what I mean? Teenager still. You're still a teenager, 18. She was 19. So we both go down, fill out the application. They said, okay, we're going to give you guys a math test. And we're like, oh, okay. I didn't know that was part of the application, having to take a math test. And you know what she asked? Can I use a calculator? And what did they say? No. Tell me about it. Well, this is the story. I was able to do the math test without a calculator. She wasn't. Who did they hire? I got the job, she didn't. What ended up happening with her? She eventually moved to the desert, far away. And her best friends were tumbleweeds. That's the story. That's her version of the story. Because it was true. She ended up moving out to, where was it? What's that desert place that everybody goes to? Huh?
Is it in California? Or
Yeah, in California. Hesperia, something like that. She moved out in Hesperia, and that's right. That's my point. That's her point. That's her point. So I think about that sometimes. What if she would have got the job and I didn't? I might have moved to Hesperia and had best friends being tumbleweeds. So math saved me. I got the job at B of A as a kid, as a teller. I was making pretty good money.
What kind of questions do they ask you though?
Math, you have to do arithmetic. You got to be able to count. They can't. You can't mess up cashing people's checks and counting money. You can't mess up. If you mess up, you'll get fired.
If you're giving too little money.
You can't mess up with the arithmetic. They'll fire you. They would do that. People would get fired. So they want to make sure. Can you do arithmetic at least without a calculator?
What kind of arithmetic were they having you do?
I don't remember. I just did it without a calculator, and I passed. I got the job. But the point of the story is, when you went out to lunch, you weren't supposed to drink.
Right.
What do you think some people would do? Drink at lunch? And they say, Daniel, why don't you come out, have lunch with us? Go have a little drink. You know what I would say? Okay. Sometimes, not all the time. Sometimes, not all the time. Only few, every now and then. All right. So it makes me think about some of that survey that if you're a working kid, sometimes you get put in adult situations. If you're around adults. Not always, but what? Sometimes. So maybe there's something to that study, you know. I don't know. But it's something I kind of think about, you know. I'm like, oh, I remember.
It's funny, in retail, mostly you see kids working.
That's right. So I don't know. Like I said, I have no idea what they really end up doing after work or during work. Who knows? But I don't know. That's just a study I remember. Working teenagers. It's interesting. Okay, what is, ladies and gentlemen, what is the claim?
That
P, what's going on with P?
P is
Is less
less than 15.
than 15%. So isn't that the less than sign? And isn't this the claim? You guys okay with that? All right, good. Where does that belong? Is that a null or is that an alternate?
That is an alternate. It's an alternate because it does not have a condition of equality.
That's right. It does not have a condition of equality. Good. Now, what's the logical opposite? It's not just greater than. Greater than or equal. Good. This is going to be, ladies and gentlemen, a left tail test. Okay, you guys okay with what we just did? That's kind of the way this works. Now, we're going to have to do our decision rule. So in our decision rule, here's the z distribution. You always look at the what? Alternate hypothesis inequality there. If that's pointing to the left, it's a left tail. Okay? So we shade the left tail. This is a do not what? Reject the null. And then over here we what? Reject the null. Use the 10% level of significance. Alpha, what does that mean? All of the 10% is in your what? Is in the tail. Is that right? You guys okay with that? All 10% is in your what? Tail. Okay? So, if we're going to use a calculator like, should we use the good one or the who knows? Let's go back to 84 plus, okay? We're going to have to use inverse norm. Remember that? Inverse norm is number 3, okay? And where's the 10%? You put 10%. That's 0.10. Is that right? 10% area to the what? To the left of the critical value. All of alpha is in the tail. Now, mu is 0, sigma is 1. It's the z distribution, standard normal. Paste that in. What's the critical value?
-1.282.
-1.28 to the thousandths? Is it a 2? -1.282. Is that critical value? So, ladies and gentlemen, they're going to always want you to have a critical value here. Because you have to know that threshold value right in here. Right? It's going to separate the two neighborhoods of the reject the null and not reject the null. All right. Decision rule setup. Let's take a sample. So when you read, what does it say? A sample of 300. What does that even mean? Good. The sample size is 300. Good. What does 28 reveal? That's X. That's your successes. So I write that down. Sample size is 300. X is 28. Don't forget. You need that little P naught. What's P naught again? Yep. P naught is always here. It's the proportion in the null hypothesis. 0.15. Okay. And I might even write down and keep track. Isn't that a left tail test? It's a left tail. So I recommend one proportion z-test. With the one proportion z-test now, right, we're going to clear this out. We're going to go to what? Stat test. I think it's number 5 still. One proportion z-test. You guys have that? All right. P naught. Oh, be careful. It's 0.15. Is that right? What is X? What's the sample size? 300. What kind of test is that? Is that a two-tail, left tail, or a right tail? Left tail. Hit enter. Now scroll down and hit what? Calculate. You guys have all that information there? You guys see that there? And what do you guys get? What's your test statistic value? What's that z value? To the nearest thousandths. What is that? Good. Look at this here. I'm going to write that down. I'm going to label what it is. This is that test statistic. They're going to always ask you that question because they want to know, where does that live on your decision rule? Negative 2.749. Isn't that further to the left? All right, I'm going to erase this. Your test statistic is like to the left of the critical value over here. Negative 2.749. Isn't that to the left? What neighborhood is this in? You got to do what? You're rejecting the null. Okay. Have you ever been rejected? Okay. Goodbye, null. If you've been rejected, we have all. If you haven't been rejected, just wait long enough, you will be. We're rejecting the null. What does that mean about the claim, ladies and gentlemen? Rejecting the null means what about the claim? The sample supports the claim, ladies and gentlemen. And the claim is that the proportion is less than 15%. So here's the conclusion. Here's what you guys can say. The sample what? Supports the claim.
Is there a reason you can't say the claim is true?
Well, it's because there's a probability here. It's a probability. Okay, this is based on a sample, which means it's not based on certainty. There is an associated error there, but in all likelihood, this is kind of a likelihood situation. That's why you're a little bit vague and you say, hey, guess what? The sample supports what the claim is. The sample. So I gave you an example where the sample supports the what? Claim as requested. Doesn't that feel so good to get that? Now go to work. Is that right? Go to work on your homework. I'm just like your parents. Work on your what? Homework. And we'll see you guys when? Monday. Take care. Stay safe.